First question they ask the SI units of stress. Stress is equal to force over area. Force is measured in Newton, area meter square, because the Newton is in the answers, that is why I select Newton, otherwise we have to select base units. Newton is in, sorry, when meter square goes up, newtons per square meter. The answer is D. Second question they ask, which row of the table only contains vector quantities? We will check first on acceleration is a vector quantity, momentum is a vector quantity, weight is a vector quantity. Then we check the other answers. Clearly we know time is not a vector quantity, density no, here mass is no, the energy is not a vector quantity. Then answer is A. A spring is stretched by applying force 3 Newton. The elastic strain energy stored by the spring is 0.04. Which of the following expressions give the extension? Extension in meter. They are given the force, energy and extension to be found. We have 3 energy equations. Energy equals half Fx, half F delta x. Delta x is the extension. Energy equals half K delta x squared, and energy equals F squared over 2 delta x. In the question, we have to connect force, energy and extension. Then this is the equation we have to select. Then from this equation, energy is 0.04, half into force 3 delta x to be found, extension. Then when you take 2 this side, 2 multiplied by 0.04, and when 3 is taken to other side, you get delta x equals this. Answer A. A cyclist moves horizontal road at a constant speed, and then moves at the same speed uphill with a constant gradient. Which of the following graphs shows how the power output P of the cyclist varies with time? When the cyclist is moving in the horizontal, on the horizontal lane, power equals force into distance divided by time. Then power equals force into velocity. Then there is a value for power. Then we have 4 answers. Let's see the 4 answers. Power is not 0 even when it is travelling on the horizontal road. Therefore, this cannot be the answer. Then we have to select from these three answers, and when it is going through the hill, in addition to friction, now we have mg is the downward force, the component of mg, component along the plane, mg sin theta. This gradient is same, sin theta doesn't change. Then in addition to the frictional force, we have mg sin theta. Now the power would be mg sin theta plus f multiplied by distance divided by time. Distance divided by time is velocity. Then this is the backward force. Mg sin theta plus mg is the backward force. Then you must give the same force, forward force, according to Newton's first law, to move the object with a constant velocity. It is given that the object is moving with a constant speed, and now the object is moving with the same constant speed, same speed. Then velocity is the same, then s over t value same for both, but here we have mg sin theta plus fv. Additional force is there, mg sin theta, but it is not gradually increasing. It must be a constant value, because here nothing will be changed when it is going up the hill. M is constant, g is constant, theta also constant. Nothing will be changed, therefore constant power should be there, and it should be greater than initial power. Therefore, answer is D. A student dropped a table tennis ball. The ball fell for time t and had a velocity v just before it hits the ground. The student used the equations of motion to calculate t and v. A ball is dropped and it hits the ground, then just before hit the ground, velocity is v, time taken is t. The student used the equation of motion to calculate t and v. These equations ignore air resistance. Without air resistance, they calculate, the student calculated. Which row of the table shows how the actual values compared with the student's calculated value? Actual value must be, the time must be greater. This should be longer time, because with air resistance, acceleration decreases. Without air resistance, we have only mg. Without drag, we have only mg. With drag, we have opposite force to the motion. Opposite force, drag force is opposite to the motion, therefore acceleration is less. With the drag, acceleration is less, therefore time taken to reach the same distance greater. Time taken is greater, and velocity hitting the ground. Velocity hitting the ground, we consider energy conservation. Then mgh is converted to, here mgh is converted to kinetic energy. But if air resistance is there, sum of energy is lost to do a work against air resistance. Therefore, kinetic energy gain is less than earlier. Then when the air resistance is there, kinetic energy gain is less than calculated. Therefore, velocity is less. Time is greater, velocity is less. A length of string is attached between two vertical posts. Actually, no need to read the question. You can see that tension forces are acting this way. And if I draw, this is 80 degrees and this also 80 degrees, because alternate angles here. So we see alternate angles like this. Then when you take the component, when you close the angle you get cos, and t cos 80, t cos 80 and another t cos 80. All together 2 t cos 80 plus 2 t cos 80 is 2 t cos 80, which is equal to W. Then t is equal to W divided by 2 cos 80. The answer C. A force is applied to stretch a spring. The graph shows how the length of the spring varies with the applied force. Applied force, usually we get force versus extension graph, but here we get applied force versus length. We get, if you draw the usual graph, force versus extension graph like this. Here applied force versus length of the spring. Then when the applied force is 0, there is a length. Then this is the original length. That means if I draw axis like this, you get force versus delta x graph. This is the original length. But when the applied force is 0, length of the spring is, there is a length for the spring. This length is the original length. Then I removed that part. And in this graph, which of the following gives the stiffness? Stiffness is equal to, in this graph, what is the stiffness? In this graph, stiffness is the gradient. The equation is F equals K delta x. The graph is in the form y equals mx. Then this is the gradient. M is the gradient, and then in this graph, gradient is K. But this graph is in the form y equals mx plus c, but the intercept is negative. But anyway, the gradient is constant. Gradient doesn't change when you compare these two graphs. Gradient is the spring constant. Therefore, even you draw applied force versus length of the string, gradient doesn't change. Gradient is the spring constant or stiffness. Stiffness. K is stiffness, or sometimes we call spring constant, or sometimes we call coefficient of stiffness. A solid cube of weight W is made from material with density rho. Which expression gives the length of each side of the cube? When weight is given and the density also given, they ask about the length. We do not have equation connecting length, weight and density, but we have equation density equals, actually here they give rho, density equals mass over volume. Then mass equals density into volume. Then W equals mg. W equals mg. For m we can substitute rho v, but actually volume is not given in the. This is a cube. Then what is the volume of a cube? Length into breadth into height. Length is L, breadth is L, height also L because it is a cube, L cube. Then m is equal to L cube rho. For V I have put L cube. Now we can substitute the mass value here. Mass is L cube rho g. I substituted this one here. Then L cube is equal to W over rho g. Then when you take the cubic root of both the sides, you get L is equal to cubic root of W over rho g. Cubic root of W over rho g. Answer 4. Force is applied to two wires. Yeah. Stress strain graphs for two wires are drawn. Which statement is correct? P has greater breaking stress. P has greater breaking stress. Stress is in this axis. Look at this. P has this. This is the breaking stress of P. Q has greater breaking stress. Therefore, this is wrong. P has greater breaking strain. Strain is breaking. This is the breaking point. Breaking strain is here. Breaking strain of Q is greater. Therefore, this is wrong. This is the breaking point. Breaking strain is this one. For P, breaking strain for Q is this one. Then breaking stress for P is this one. Breaking stress for Q is this one. Then P has greater yield strength. Yield point is this point. This is the yield point. Any graph, if there is a graph is changing like this, like it is the yield point. P has greater yield stress than Q. P has greater yield stress. Look at this. P has greater yield stress. That is correct. But P has lower yield strain. Look at this. When you compare strain, P has lower yield strain but greater stress. This is correct. And we check the other one as well. P has a lower Young modulus. P has the greater Young modulus because gradient is the Young modulus. Gradient for P is greater. Therefore, P has greater Young modulus. Then they say P has lower Young modulus. That is wrong. Yield stress is greater for P. This is the answer. An object moves with uniform acceleration for time t. The acceleration time graph for the object is shown. X is the area under the graph between 0 and time t. Which of the following expression gives the distance moved by the object? Uniform acceleration. This is a uniform acceleration. Then we get the change in velocity. Change in velocity is equal to area. Yeah. Area under acceleration time graph is change in velocity. Area under velocity time graph is displacement. Now, here change in velocity means the object start from rest, then x is the area, x is equal to initial velocity 0, change is final minus initial, change is final minus initial, initial is 0. Okay. Then initial velocity is 0, final velocity is v. Then to find the distance, how do we find the distance? This is not a constant velocity. If it is a constant velocity multiplied by time gives the distance. Here we found the change in velocity, initial velocity 0, final velocity v. Therefore, what is the average velocity? We have to find the average velocity. To find the average velocity multiplied by time is the distance. Then what is average velocity? Average velocity is initial velocity plus final velocity divided by 2. Then here we found x is equal to v. Then final velocity is equal to x, because v minus 0 is v. Change in velocity is the area under the graph. Then area under the graph is equal to v minus 0. Then v minus 0 is v. Then here we wrote average velocity multiplied by time gives the distance. Okay. Now for v I can substitute, x. 0 plus x divided by 2 multiplied by t equals distance. Here we can ignore 0, then when you multiply x multiplied by t divided by 2. X multiplied by t divided by 2 is the answer.